Hello guys, this is Shakti and I am MPG scholar of M.TECH University, M.TECH Technical University. Okay. And this is what of my project item, Geographical Image Retrieval using Spatial Filtering for Image Enhancement. And my guy name is Mr. R. Nagaran, M.TECH, Assistant Professor of Information Technology. And this is my final year project. What my project objective is in the friends. The aim of image enhancement is to improve the interoperability or perception of information in images for human viewers or to provide better input for other automated image processing techniques. Then, there is no general theory for determining what is good image enhancement when it comes to human perception. So most of the image enhancement techniques Most of the image recognition technique used, so no one has the better image, but it will satisfy the human viewers. So the next one is abstract. What I'm going to do in my project, the main aim of this project is to do better enhance the image for human viewers, where the image contains noise, blur, obstructions due to climate changes, night vision, cloud, rainy season, and any unconditional climate captures. It contains information that is unknown format. In the sense, information will present within the image that we propose. Some methods that will give us good informative image on above conditions. By selecting first hypothesis selection filter, it's nothing but it's a collection of filtering technique used like linear, non-linear version for the process of removal of noise, blur, salt, and pepper images. So this is the main thing while we processing the image processing. This will provide the better to get the tracker and normalized image. Another one, contrast limited adaptive histogram interpolation. For the night vision image to get the better normal image information. While using this contrast limited adaptive histogram interpolation, we will perform the contrast enhancement processing. And final one is Gabor filter performs the weather forecasting and condition image analysis. Then, introduction. Purpose. The main aim of this project to develop in this project. Linear nonlinear filtering for image quality enhancement is the proposed method. So, what I said as it is in before. Project scope. In recent years, the image processing is to determine the better visual appearance. Nowadays, it's difficult to get visual images. So because captured image contains a list of unconditional format due to the elimination changes, night visions and unpredictable climate conditions because noise, blur, salt and pepper images. The digital image processing gives us the better enhancement techniques for the types of image to get the desirable information in that. So the survey of an image enhancement process has been increasing explosively and analyzing the images research area on the weather forecasting community. Some of the filtering techniques provide better enhance the image to user to get the appropriate information within the image. The advanced hypothesis selection filter and contrast limited adaptive histogram interpolation filter are used here to get good visual. My existing system. In existing, we are using the three filtering techniques. First one is adaptive motion model, second one is spatial temporal model, the third one is adaptive likelihood function. They are going to capture the image. The image device is placed in the unmanned aerial vehicle. So they are going to capture the image and monitoring the particles. They won't concentrate about the picture resolutions. So that's the most disadvantage. And unmanned aerial vehicle, it will fly over the limited height only. So in this sense, adaptive motion model is presented which controls the spreading of the particle cloud in which such space of each vehicle. Second one is spatial temporal particle guiding approach. So it includes the context of adjustment vehicles into the tracker to increase the stability of the tracker. Okay, then this is the good one also. Then appearance changes of the vehicle are handled by the template update strategy. Then another one is adaptive likelihood function. It's introduced to balance the flexible and strict observation mode. In this particular process, it gives the low quality only, and then tracker won't able to monitor the what's the strength and the resolution, what's the capability of the image within the image information what I want to get. So they are going to monitor and monitoring the purpose only they are using this process. As an unmanned aerial vehicle, it will fly only the limited height only. Due to the climate change conditions, it will get normalized or unnormalized image. So the tracker it won't get normalized tracking facility. So what we proposed in this project, the linear nonlinear filtering for image enhancement is the proposed method, and then I'm going to propose a new technical filtering technique. It's called a micro and telescopic filtering technique. It's nothing but microscopic filtering technique. It's also called to use in the medical field or areas. Then telescopic filtering technique because you guys are also known what is telescope and microscope. The hypothesis selection filter serves as a framework for combining the outputs of a number of different user-selected filters, each best suited for a different regions of an image. The histogram equalist has a better contrast enhancement technique. And what is the advantage of my project? It's going to give the better enhanced image for illumination changes and a better enhanced resolutions, live and real-time updating to the user. These are my researcher surveys, what I'm going to refer to update my project. And my modules are first one is pre-processing, the second one is filtering, third one is image analysis, and final one is optimum solution. Then first one is pre-processing. In that contrast adjustment and intensity adjustment, histogram equalization and adaptive histogram equalization, and final one is contrast limited adaptive histogram equalization. And first one is contrast adjustment. The contrast of an image is the distribution of its dark and light functions. Then the light contrast image exhibits small difference between its light and dark pixel values. So this is the original and the contrast adjusted image. For the sample image, I'm going to give you this. Second one is intensity adjustments. It's based on the subjective and objective voice. So first, image enhancement techniques are used to improve an image that improve is sometimes different objectively, increasingly, and signal to noise ratio. Objectively in the sense increase the signal to noise ratio, then subjectively in the sense make a certain features easier to see by modifying a colors or intensities. Then third one is histogram equalization. This is nothing but this is the commonly used contrast enhancement techniques in most of the image processing techniques. This is usually increase the global contrast of images, especially when the usable data of an image is represented by the close contrast values. Then through this adjustment, the intensities can be better distributed on the histogram. Okay. This allows for areas of lower local contrast to gain a higher contrast. Then probability density function is calculated for the histogram equation. This is the mathematical algorithm is going to undergo into for the histogram equalization. And this is what the sample image I am going to be doing. So PDF can be approximated using the probability expressed as follows. This is the format, and output pixels from the histogram equalization operation are equal to the cumulative distributive of an image. So this is the first one is this is the PDF of probability density function is the input function, and cumulative distribution function is the calculation function of the image. Then second one is adaptive histogram equalization. This is nothing but the advanced version of hypothesis selection. Advanced version of an histogram equalization. This is also do the what we are going to face in the histogram equalization function drawback, and then adaptive histogram equalization is going to overcome this process. And final one is contrast limited adaptive histogram equalization technique. This is the wide areas technique, contrast limited wide area contrast adjustment technique in image processing. The final one is filtering techniques. Here I am going to use the hypothesis selection is advanced hypothesis selection filtering. The collections of filtering techniques which is I am going to use which is I am going to use in the first one linear and non-linear selection filters because my project is based on the geographical image analysis. So that only I am choosing the spatial filtering techniques, then gamma filter, then Gaussian under the Gaussian. So these are the techniques. So what is the spatial operation in the sense? So this is going to classify into smoothing and then next one is smoothing and sharpening filtering. So smoothing in the sense, for example, purpose filtering techniques is going to reduce the noise and eliminate small details. The element of the mask must be positive. Sum of the mask element is 1. It's after the normalization. Smoothing filters by using the Gaussian technique very effective for removing salt and pepper noise and occurrence of black and white pixels. So this is the sample image, the average and filtered image. Then smoothing the medium filter to the sharpening. So this one is the second method of spatial filtering filter. It's also called as high pass filter. Highlight final details or entrance detail that has been blurred. So this is going to be better while removing the salt and pepper and blur the noise from the image. Then the element of the mask contains both positive and negative weights. Sum of the mask weight is 0. After the normalization, it's going to obtain a sharp image by subtracting a low pass filter image from the original image. Then final stage is image analysis techniques. The goal is to extract the important feature from image data from which is a description or interpretation or understanding of the scene can be provided. Image analysis can be used based on the content-based image retrieval techniques. It's based on the color, texture, and information. Based on the information wise, these content-based image enhancement techniques will be used. The final stage is optimum solution. The performance of algorithm is tested and compared to the standard filters. What I'm going to do in this stage, optimum solution, to get the immediate result of an immediate and fast filtering result, because our project is going to be perform the live geographical image enhancement techniques. Then I'm going to my running section. Most of the geographic information system users basically use environmental visualization information system, that's also known as ENVA versions. This is the famous and research-oriented area for weather forecasting and image analysis technique use in real-time world. But I'm using MATLAB image going on to explain. By using the ENVA 5.2 Geographical information system, we will get the immediate and extract and the exact information what is going to present within the captured image. It contains image blur and all those things. So this is what I might go to filtering codings. So I'm going to run this. I am using IM so it doesn't exist. So we have to change that for the where it is my images. paste the images here. I'm going to change the image directory. So yeah, for the change first. Let's see. So this is what it is. Due to the different climate condition, I have some images. You will see already. This one set of normal image. Second one. This is what I got. Due to the climate condition changes, rainy and cloud type and night conditions. So this is the image processing I am going to apply. You can see the final result. So this is what I got, my final image. So with the image content, what I'm going to actually explain is salt and pepper. It's not the matter. But nowadays, what the problem is, the climate is the most important problem due to the lack of problem in environmental science. This is the one set of set of images. This is what I want. This is science of images. This is third second. So this is the error image, and this is what I'm going to apply the image processing techniques, and this is what I find out what I'm going to get the final result. So the next one is so this is a advanced quantum center adaptive astronomical session of image processing techniques. Most of the research-oriented people based on the processing techniques, they are making the major mistake. They want to analyze the image, what he got in. The research-oriented people are concentrated a bit. So what's the information within the image they are capturing? In the sense, they are going to get that. accurate and predicted information. This is what the second possibility is. So this is what my actual image. Next one. This is what I got. If my unmanned aerial vehicle captured device got some error due to some climate changes. And this is what the second one said. This is what within the image present. Then this is what my screenshot of normal image. And this is what actual image within the blur or somewhere. Thank you for watching this. I hope this is going to really helpful to you.